Hello everyone, welcome back to our series of sessions in trigonometry. So in continuation of applications of various trigonometric identities, we are we were doing some problems in the previous session. So this is a continuation of those. So the first question, that is question number 26. Tan A, you have to prove that tan A divided by 1 minus cot A plus cot A divided by 1 minus tan A equal to 1 plus secant A multiplied by cosecant A. So let's take the left hand side and convert tan as well as cos in terms of sine and cos. So tan A can be written as sine A divided by cos A whole thing divided by 1 minus of cot A. Cot A can be written as cos A divided by sine A. This entire thing plus cot A, it is cos A divided by sine A, whole thing divided by 1 minus of tan A is sine A divided by cos A. So the first one we will write it as sine A divided by cos A, and the denominator we have the LCM as sine A. We have sine A minus cos A. Plus cos A by sine A. That is the numerator. Denominator again, the LCM will be now cos A. Numerator will become cos A minus sine A. So let's proceed. We have sine A by cos A. Multiplied by the reciprocal of the denominator, sine A divided by sine A minus cos A. Sine A divided by sine A minus cos A, plus the numerator of the second factor is, the second term is cos A by sine A, cos A by sine A. Then we will write the denominator as a reciprocal because we are multiplying it. Cos A divided by cos A divided by cos A minus sine A. Cos A minus sine A. So if you look into this term, I'm talking about this term and this term, we may not, only the sign is changed. That means if I want to bring it to the same style, then I should take the negative sign outside. So I can bring this negative sign outside so that I can write this as sine A minus cos A. That's what we are going to do in the next step. So here numerator will become sine square A divided by cos A into sine A minus cos A, and I said we are going to take out this negative sign outside, so I am putting it, instead of plus I am putting it as minus. So you have here cos square A divided by sine A into, now since we have taken negative outside, we will write sine A with the positive, cos A with negative. Now we may note these two terms are same, sine A minus cos A are there in both these terms, right? So we will take it outside as a common term, 1 by sine A minus cos A, that is taken outside. Then first term will be sine square A by cos A minus cos square A by sine A. Now again 1 by sine A minus cos A. Now in this term, we'll take out the LCM as sine A cos A. That means this will become sine cube A minus cos cube A. This is like A cube minus B cube. A cube minus B cube, we can write it as factor, we can factorize it as A minus B into A square plus AB plus B square. Using our algebraic identities, we can write like this. So that means the numerator can be written as sine A minus cos A multiplied by A square. A square is sine square A plus AB, that means sine A cos A plus B square, that is cos square A, divided by sine A minus cos A multiplied by sine A cos A. We can cancel this term with this term. Now this one, that is sine square A plus cos square A, that is, we know it is 1. So we can write it as 1 plus sine A cos A divided by sine A cos A. So if we split this, we will have 1 by sine A cos A plus sine A cos A by sine A cos A. Means what I did is I divided individually. 1 divided by sine A cos A, I wrote it. Sine A cos A divided by sine A cos A will become 1. Now what is this term? 1 by sine A, we know it is cosecant A. 1 by cos A, we know it is secant A plus 1. I think this is our RHS. Yes, that is nothing but our RHS. Hence the proof. Next question is to prove this. So let us start with our left hand side. I can write it as 1 plus secant A can be written as 1 by cos A divided by 1 by cos A. Numerator, the LCM will be cos A. So cos A plus 1 divided by 1 by cos A. We can cancel this cos A and this cos A. So ultimately we are left with cos A plus 1. What is this? This is our LHS. Right. So now let us start with, let me call this as 1. Let us now start with RHS. RHS is sine square A by 1 minus of cos A. Sine square A can be written as 1 minus cos square A using the first trigonometric identity, which is sine square A plus cos square A is equal to 1. That means we can write sine square A as 1 minus of cos square divided by 1 minus cos A. So here this 1 can be written as 1 square. So it looks like, in the numerator it looks like A square minus B square. We can write that as A plus B, means 1 plus cos A into 1 minus cos A divided by 1 minus cos A. This can be cancelled with this. So we are left with 1 plus cos A. Call this as 2. We may note 1 is equal to 2. So we can conclude hence the proof. Let's move on to this next question. Start with LHS. There is sine A plus cosecant A the whole square. It is like A plus B the whole square. So let us expand it. A square plus 2AB, 2AB plus B square. Then this is about the first term. Let me put this expansion is for the first term within brackets, right? Okay, then second term, again A plus B the whole square. So A square plus 2AB plus B square. Now, if we add this plus this, it is 1, right? So then, if we look into the sine A and cosecant A, means sine A and cosecant A are inverse to each other. That means I can write this cosecant A as 1 by sine A. That means sine A into 1 by sine A, this also becomes 1. That means this entire term will become 2 into 1. So it is 2. Similarly, come to here, this cosecant A and secant A are reciprocals to each other, which means secant A can be written as 1 by cos A. So cos A into 1 by cos A becomes 1. So 2 into 1 is 2. Means I have written this. I am now writing this as 2. Now what is left? We have cosecant square A plus secant square A. So this is together 5. And what is cosecant square A? Using the trigonometric identity. What is that? I think it is the second trigonometric, third trigonometric identity. Cosecant square A can be written as 1 plus cot square A. Similarly, second trigonometric identity, secant square A can be written as 1 plus tan square A. So that means if we add these three, we have 7 plus cot square A plus tan square A, which is nothing but our right hand side. Let's move ahead. Start with left hand side. Cosecant A can be written as 1 by sine A minus sine A multiplied by secant A can be written as 1 by cos A minus cos A. So if we take the LCM for the first term, it is sine A. So this will become 1 minus sine square A. And here LCM is cos A. This numerator will become 1 minus cos square A. So what is that? Here the numerator will become 1 minus sine square A is cos square A. 1 minus cos square A is sine square A divided by sine A cos A. So one term will get cancelled, means sine square A divided by sine A will become sine A. cos square A by cos A will become cos A. So I can write this as cos A sin A. This is our left hand side. Call this as 1. Now start expanding right hand side. 1 divided by tan A can be written as sin A by cos A. Cot A can be written as cos A divided by sin A. So now 1 divided by, let us take the LCM. LCM is cos A sin A. So here it will become sin square A. This will become cos square A. So that means this is 1 divided by 1 by cos A sin A. 1 divided by inverse of cos A sin A, that will lead to cos A sin A. Call this as 2. Now we may note 1 is equal to 2. So hence the proof. Right. Let's move on. Start with left hand side. 1 plus tan square A. I can write that straight away using the second trigonometric identity as secant square A, the numerator. Denominator 1 plus cot square A, third trigonometric identity, which I can write it as cosecant square A. So what is that? Secant square A can be written as 1 by cos square A, and divided by means divided by cosecant square A can be written as 1 by sine square A. So how do I write it now? This I can write it as 1 by cos square A divided by, that means multiplying by its reciprocal. So sine square A by 1. Now sine square A by cos square A can be written as sine A by cos A the whole square, which is nothing but tan square. That is our right hand side. Hence the proof. We have proved it. So what we did in this session is that some of the usage of trigonometric identities, we try to solve these problems starting from 26, I think. Yeah. 26 to 30. So that's all in this particular session. We'll meet again in our next video session, which will be again in trigonometry only. Till then, see you all. Take care. Thank you.